Good afternoon, everyone. My name is Weizhong Zhang, a staff fellow from Division of Bioinformatics and Biostatistics in National Center for Toxicological Research, USFDA. In NCTR, most of my work was applying data mining approaches to analyze the biological data. Recently, I was using text mining tools to do the EHR data analysis. Today, I will use our study in CDB project to show how to use topic models in text mining. The title is Best Practices in Building Topic Models for Mining Regulatory Textual Documents. In this presentation, I will first give the background and basic idea in topic models. Then I will present the study design and result analysis. Topic model is a statistical tool which has been widely used in different research fields. The basic goal of topic modeling is to facilitate information retrieval. Although it's powerful, there are still some inherent limitations. First, model validation of topic modeling as well as other text mining methods is mainly subjective. Second, there are no quantitative means to measure if truth has been found when truth is not known. Truth here means the label of samples. Thirdly, limited quantitative means to measure fit to data or prediction accuracy. Last but not least, topic modeling is a data-driven unsupervised learning. The parameter setting may affect the effectiveness of the method. This slide shows the basic idea of topic modeling. The topic modeling is the popular approach for text mining. It's used to discover the main themes that provide a large collection of documents. Here are basic definitions in topic modeling. Word is an item from a vocabulary. Document is a sequence of words. All of the documents constitute the corpus. This figure shows the idea in topic modeling. Each document has a mixture of documents. Each document has a mixture of topics. Each topic is expressed by distribution of words. Latent directed allocation, or LDA for short, is the most popular topic modeling approach. This figure presents the schematic representation of the LDA. In LDA, mixture of topics in each document is modeled as a multinomial random variable theta, and all of the thetas are generated by directly prior distribution with parameter alpha. The distribution of words for each topic is also modeled as a multinomial random variable phi, and all of the phi's are generated by directly prior distribution with parameter beta. Based on the observed words in documents, appropriate inference method like variational inference or Gibbs sampling can be used to calculate the posterior distribution of theta and phi. Following data analysis can be conducted on the posterior distribution of theta and phi. In this study, we did comprehensive experiments to investigate how to determine the parameters in topic modeling. Also, we test the effectiveness of the topic modeling. This slide shows the workflow of this study. First, a ground truth dataset was constructed by search of PubMed database with combination of match terms related to the tobacco use and health concerns. Each combination of match terms was viewed as a theme or true label of samples, and the obtained abstracts was annotated as the corresponding theme. For example, tobacco use or smoking and lung neoplasms was used to retrieve a theme related to smoking and lung cancer. In the whole study, 41 themes were used. Some of them have somewhat overlapping. After pre-processing, LDA methods was applied on the processed dataset to obtain two matrices. One matrix is the document topic matrix, and another matrix is the topic word matrix. Actually, the two matrices are the posterior distribution of theta and phi. By comparing the obtained topics and the themes of PubMed search, we can evaluate the effectiveness of LDA method. In the following slide, I will present the detail of each step. This slide shows the 41 themes used in document retrieval and the number of obtained abstracts. The 41 themes include 14 smoking-related cancers, 18 smoking-related diseases, excluding of cancers, 7 smoking-related health issues, and 2 smoking-free themes as the negative control. For each theme, the downloaded abstracts were used as document in this study. Since some themes have overlapping, we removed the duplicates in the whole dataset. Finally, we have a total of 59,201 abstracts in this study. This slide shows the screenshot of the information retrieval in PubMed database. After applying topic modeling to a dataset, 2 matrices were obtained. The document topic matrix exhibits the topic probability in each document, which is used to describe the differences among documents. The topic word matrix exhibits the word probability in each topic, which is used to delineate the differences between topics. Based on document topic matrix, a method called diagnostic topic method was used to select the relevant topics to each theme. We compute an average topic distribution for documents belonging to the same theme. Then the average topic distribution of different themes were normalized by topics. For each theme, topics with a higher normalized mean probability are identified as the relevant topics. Word cloud approach is used to visualize topics in which size of words are proportional to the probability of words in a topic. Combining the diagnostic topic method and the word cloud approach, we can compare the obtained topics with themes in ground truth dataset. In the whole study, our experiment consists of 2 parts. The first part, we investigate how to determine the parameters in topic modeling. In the second part, we evaluated the effectiveness of topic modeling. As I mentioned, topic modeling is a data-driven model. Appropriate parameter setting is important for the quality of the topics. 3 parameters play key roles in topic modeling: the topic number, the hyperparameters alpha and beta. Hyperparameter alpha affects the document topic matrix, and hyperparameter beta affects the topic word matrix. In the parameter study, perplexity measurement was used to evaluate the model fitness. The smaller of the perplexity value, the better of the model fitness. Four-fold cross-validation was conducted in each experiment, and the average perplexity was used as the final model fitness. I want to know that the LDA implemented in the Mallet was used in our experiment. Mallet is a free Java-based package for text mining and developed by Andrew McLean of the UMass. This study the result of how the topic number affects the perplexity. The 2 figures show the model fitness of the topic modeling with a different number of topics on training and testing datasets. In each figure, the x-axis is the number of topics, and the y-axis is the perplexity. Topic numbers 25, 50, 100, 200, and 400 are used. Other model parameters were with the same setting. In our experiment, we set alpha as 0.1 and beta set as 0.01. The experiment was conducted on 4 different sizes of datasets, which have 1,000, 2,500, 5,000, and 10,000 respectively. Each line in the figures represents the result on one of the 4 datasets. Results show that the good topic number is in the range of 100 to 200. In this slide shows the result of how parameter alpha affects the probability. The two figures show the model fitness result on training and testing dataset. The x-axis is the alpha value from the 0.01 to 1. For each line, we keep other parameters same and change the alpha value. We set beta as 0.01 and did the experiment with different number of topics: 25, 50, 100, 200, and 400. The results show that topic modeled with alpha value from 0.01 to 0.1 have the best model fitness. The overfitting was not observed even for the topic model with 400 topics. The result of how parameter beta affects probability show that beta value 0.01 usually derive the best model for the dataset. This slide shows the comparison result of the topic modeling with symmetric alpha and asymmetric alpha. In topic modeling with symmetric alpha, alpha value is fixed during optimization, while in topic modeling with asymmetric alpha, alpha value is also updated during optimization. Probability from asymmetric alpha is more stable than asymmetric alpha. Probability with asymmetric alpha is more stable than symmetric alpha in range of 0.01 to 1. And based on the result of probability study in the rest of the study, all of the results were obtained by topic modeling with 100 topics, asymmetric alpha set as 0.01, beta set as 0.01. In the following slides, I will show the validation experiment result on the ground truth data. The first question we want to answer is, can topic modeling find ground truth? This slide shows the most relevant topics to the document subset with theme smoking and cessation, which consists of 26% of the total documents in the whole ground truth dataset. The table presents the most related topics by diagnostic topic method. The first line is the topic ID, and the second line is the normalized probability. The topic with the maximum normalized probability is topic number 40. The word cloud of the four most related topics are presented as well based on the topic interpretation. Topic 40 is talking about the cessation program. Topic number 58 is talking about cessation therapy or treatment. Topic number 91 is talking about study of intervention for cessation, and topic number 63 is talking about training and education for cessation. Results show that the topic modeling method can discover the theme with large number of abstracts, and the theme with large number of abstracts have multiple relevant subthemes. The second question we want to answer is, can topic modeling delineate intentionally overlapped ground truths? This slide shows the result on two highly overlapped themes. The first theme is smoking and cardiovascular diseases, and the second theme is smoking and heart diseases. Note that the second theme is completely overlapped by the first theme. From the top 10 most relevant topics of the two themes, 9 of 10 topics are same, but using the first two most related topics can differentiate the overlapped truths. This slide shows the result on another two overlapped themes with the overlapping ratio is less than the example in the last slide. The first theme is the smoking and heart diseases. The second theme is the smoking and stroke. From the result, we found that 7 of the most related topics are overlapped. Also, it can identify the differences among the two themes. For example, the most relevant topics to theme smoking and heart diseases is topic number 21, which is talking about the cardiovascular diseases, while the most relevant topics to the same smoking and stroke is topic number 88, which is talking about the stroke. The third question we want to answer is how sensitive are topic modeling in detecting themes with fewer documents. This slide shows the result on theme smoking and stomach cancer, including 500 to 26 abstracts, about 0.9% of the total abstracts. The top three most related topics are topic number 35, talking about the gastric and bladder cancer, topic 7, talking about the gene polymorphisms, and topic number 0, talking about the nutrition. Obviously, topic number 35 is related to theme smoking and stomach cancer. For topic number 7 and topic number 0, most related abstracts are also listed. For topic number 7, the most related abstract with PubMed ID 1937 5306. After checking the article manually, we found that it's talking about the associations between genetic polymorphisms and gastric cancer. For topic 0, the most related abstract with PubMed ID 88, 50, 43, 4. After checked the article, we found that it's talking about the association between nutrition and the stomach cancer treatment. And therefore, we know that these two topics are really related to theme smoking and stomach cancer. This slide shows the result of another theme with fewer abstracts. The theme is smoking and child malnutrition, including only 10 abstracts. The topic children's exposure to smoking is identified as the most relevant topic. These two examples show that topic modeling can detect theme with fewer documents. The question 4 we want to answer is, can topic modeling identify the intruding documents? In other words, if topic modeling can identify the negative control themes. This slide presents the diagnostic topic method on negative control theme, foot injury. The top two most related topics are topic number 66 and topic number 24. Topic number 66 is talking about the foot injury. The topic number 24 is talking about the foot reconstruction. The results show that the topic modeling can identify the negative control themes in ground truth data. And in summary, the topic modeling easily distinguishes ground truth in qualitative documents across many themes. It even reveals numerous sub-themes. Second, topic modeling also differentiates overlapped ground truth. Topic themes with minimal documents can be detected by topic modeling. Topic modeling can recognize the intruding themes, and finally, topic modeling appears to find the truth if they are to be found. And that's all my presentation today. Thank you for your time.